Hello, good morning. I will go over Spring 19, Math 245, Task 4. Number 1, compute the exact value of this log base 3 of 27 times cube root of 9. Let's call this x for a while. So if we rewrite that in exponential form, that will be 27 cube root of 9 equals to 3 to the x. So you see the base is base 3, right? So this is 3 cubed. This is 3 squared to the power of 1/3 equals to 3 to the x. This is 3 cubed times 3 to the 2/3 equals to 3 to the x. This is 3 to the 3 and 2/3 equals to 3 to the x. So x is 3 and 2/3. Or you can also say 11 over 3. Number 2, you know what? Let me zoom that a bit bigger. Number 2, 3 to the x squared minus 10 equals to 27 is 3 cubed to the x. So 3x squared minus 10 equals to 3 to the 3x. By 1-to-1ness of base 3, we get x squared minus 10 equals to 3x. So x squared minus 3x minus 10 equals to 0. Oh, we can factor this x minus 5, x plus 2 equals to 0. So x1 is 5, x2 is -2. Number 3. We have base 9, we have base 3. Oh, I can rewrite this into base 3. So this is 3 squared to the power of x minus 3 to the x plus 2 plus 8 equals 0. So this is 3 to the 2x minus 3 squared times 3 to the x plus 8 equals to 0. I will rewrite this as 3 to the x being squared minus 9 times 3 to the x plus 8 equals 0. Now, the purpose is so that we can do quadratic-like equation. Let u equals to 3 to the x, such that our equation now becomes u squared minus 9u plus 8 equals 0. Oh, we can factor that. So u equals to 8 or u equals to 1. 3 to the x equals to 8. 3 to the x equals to 1. So x is log base 3 of 8, or x equals to 0, right? This is 3 to the 0. Okay. Number 4, solve this log equation. Log blah equals to log bleh means by 1-to-1ness, blah equals to bleh. And then x minus 4x minus 12 equals to 0. X minus 6, x plus 2. So x equals to 6 and x equals to -2. But we need to make sure that when we plug that into the argument, we have positive. So you see what happened is when I plug in 6 here and here, both of them positive. So x equals to 6 is okay. However, when I plug in x equals to -2, it becomes -8 here. So it is not okay there. Okay, cross it out. So we still write x equals to -2 first, but then you cross it out. Okay. Number 5. 5 times 8 2dx equals to 12. Solve this. I will divide by 5 first. I think that's 2.4. So log base 8 of 2.4 equals to x. That's the exact solution. Now then, if we want the approximate solution, we need to do the change of base, natural log of 2.4 over natural log of 8. That is equal to, then we use our calculator. And you can use log base 10 too, that's fine. I get 0.42101 in 5 decimal places. Okay, that's for page 1. Let's go on to page 2. This is a rational function. Let's factor it first. So fx equals to, I factored it 2. I get x squared minus 4. At the bottom, x minus 3, x plus 1. I can factor the numerator further. This is 2 times x plus 2, x minus 2 over x minus 3, x plus 1. Now, so then the key is actually with the factoring though, okay? So the domain will be all real numbers except 3 and -1. Boom. Because once you factor it, you know, you just need to know what to look at to find these answers here. The y-intercept is when f0. F0 is -8 over -3. So 0.8 thirds. That's almost 3 between 2. That's approximately 2.6, 2.7. Okay, the x-intercept, we will look at the numerator. 2x plus 2x minus 2, set it equals to 0. So x equals to -2. That's in the domain. X equals to 2, also in the domain. So the x-intercepts are -2, 0, 2, 0. Horizontal asymptotes. The degrees are the same, degree of 2 on the top, degree of the 2 at the bottom. So horizontal asymptote is y equals to leading coefficient over leading coefficient. So the horizontal asymptote y equals to 2. And don't forget, it has to be a linear equation. It's y equals something. Vertical asymptotes, that's when the denominator equals to 0. So either x equals to 3 or x equals to -1. Okay, now how about the sine graph? Let me write it down again. So 2x minus 2, x plus 2, x minus 3, x plus 1. So the critical numbers are x equals to 2, x equals to -2. On the numerator, x equals to 3, x equals to -1 on the denominator. And then we do the sine graph. -2, -1, and then 2, and then 3. It is undefined on -3 and -1, 0 on 2 and -2. And then you do the sine graph, but we have the the y-intercepts. The y-intercept is positive. So this is positive here, positive, and each of the critical numbers has multiplicity of 1, right? Now, then part G, use part F using that sine graph to solve this, the function to be less than equals to 0, means we need the negative. Using that, we get then -2 to -1. That's negative part, right? Union from 2 to 3. Okay, that's for part G. And then part H, sketch the graph. Let me start with horizontal asymptote y equals to 2. Y equals to 2. And vertical asymptote x equals to 3. And x equals to -1. The x-intercepts are, let me use a blue color, x-intercepts are -2, 0 and 2, 0. And then what else? The y-intercept is 0, 8/3, so like this. And we can plot more coordinates. Let's say what is f -4. Let's see what is f -4. Let me write down here. And oops, sorry. F x equals to 2x squared minus 8 over x minus 3x plus 1. You know what? Let me write them out in factor form. It's easier to compute actually. So x minus 2, x plus 2. So if I have f4, f -4, that will be 2 times -6 times -2 over -7 times -3. That'll be positive 24 over positive 21. That's 8 over 7. -4, a little bit over 1. Oh, I think it will. And how about F4? So that's 24 over 5. That's 4.8, huh? 4, 4.8. 4, 4.8 here. Let's see how about F6. So 6 times 8 is 48 divided by 21. That's 2 and we can reduce by, huh? Am I okay? 6 times 8 is, oh, that's 8 times 8, that's 64, my bad. So that's approximately 3 times, huh? Approximately 3 times. So 6 comma approximately 3, 6 comma approximately 3, like this. Okay, so the graph will be approximately, it must come from horizontal asymptotes and then go down, right? And then use that sine graph to help. And 6 is approximately 3, not 2, my bad. So it should be approximately here. Not 2. Yeah, okay. So approximately that's what you can plot more coordinates to have a better feeling about what the graph should look like. Okay. In fact, we can do something though. I can do something. I would like to know if we have horizontal asymptote intercept. Now, if you do this in your test, then I give you extra credit. Okay, maybe 1 or 2 points. Equals to the horizontal asymptote. So 2x squared minus 8 equals to 2x squared minus 4x minus 6. 2x squared cancels. This is negative 2 equals to, this one already killed. So I add 6 equals to, so x equals to 1/2. So we have horizontal asymptotes 1/2, horizontal asymptote intercept 1/2, 2. 1/2, 2. This way I actually noticed that I make a mistake in my graph here. So 8/3 is more than 3. And 1/2, 2. So the graph's supposed to look like this. Yeah, good thing I checked that one. Otherwise, even my y-intercept is incorrectly placed. Okay, that's for this number 2. Number 3, always factor first. Always factor first. So the top one, I will factor by grouping. So I get x minus 3 times x squared minus 1 over x plus 3, x minus 3. So fx now becomes x minus 3 cancels. So it will be x plus 1, x minus 1 over x plus 3 when x is not 3. But if x equals to 3, it becomes undefined. So we will have a hole here. Okay, the domain will be all real numbers except negative 3 and 3. The y-intercept f0, or you can also use f star 0. f0 is 3 over negative 9. That's negative 1/3. So the y-intercept is 0, negative 1/3. The x-intercept, look at the f star 0. You still need to check against the domain later on. So the x-intercepts are 1, 0, negative 1, 0. The vertical asymptote x equals to negative 3. It starts from here. Now, oblique asymptote, you can just use f star x. F star x is f star x is x plus 1, x minus 1 over x plus 3, right? And because we divide by x plus 3, we can just use syntactic division. So the slant asymptote, oblique asymptote is x minus y equals to x minus 3. How about the sine graph? The critical numbers are x equals to 3, x equals to 1, x equals to negative 1 on the top, x equals to negative 3 at the bottom. But x equals to 3 also a critical number on the denominator, which will make it undefined. So when we do the sine graph, that would be negative 3, negative 1, 1, 3. It's undefined on negative 3 and 3, 0, and 1. And the y-intercept is negative. So when x equals to 0, when x equals to 0, that's negative here. Multiplicity for each one of them is odd, except when x equals to 3. When x equals to 3, it has a multiplicity of 1 at the top and another 1 at the bottom. So it has multiplicity of 2 in total. Okay, so that's no change of sign here, but for the rest, we have change of sign. Okay, now use that part. F to solve for this, we need a positive part. We need a positive part. So to be positive, we will get from -3 to -1, including union from 1 to 3, union 3 to infinity. Okay. And find the coordinate of the whole. That's basically F star 3. So you replace this. This is our F star here. This is our F star. This is our F star. Okay, that's our F star, X. Now plug X equals to 3 into that F star. So 3 plus 1 times 3 minus 1 over 3 plus 3. That is 4 times 2, that's 8 over 9. So the coordinate of the whole will be 3, 8 over 9. Now put things together. The y-intercept 0, -1/3. It's here approximately. The x-intercepts are -1, 0, 1, 0. Oh, by the way, do not rescale it though. Do not rescale it. Just use that one. Okay, every grid represents 1 unit. And then we have vertical asymptotes, x equals to -3. And then slant asymptote, y equals to x minus 3, x minus 3. So the slope is 1. The y-intercept of that line is 0, -3. So this is what the slant asymptote look like. Okay. We have a hole at 3, 8 over 9. 1, 2, 3, 8 over 9. So we have a hole here. So the graph will go through that hole, of course, not including that hole. Okay. So the graph later on, when I pull that, it will look like this. Now feel free to get more coordinates though. Okay, let's say I will use x equals to -2, okay, so that I have a better graph. X equals to -2. So f star x equals to x plus 1, x minus 1 over x plus 3. So f star of -2 will be -1 times -3 over 1. That's +3. So that's -2, 3. -2, 3. Okay. Now how about when x equals to 4? -4. F star -4 will be -3 times -5 over -1. That's negative 15. Oh, that's very far down there already. So it should be like this. Okay, that's what the graph looks like. You still need to give this branch though. You still need to provide that branch. Even though it's outside of the plane already, I still want you to give me that branch. Okay, just to represent, okay, you know what's the shape look like? Okay, that's what it looks like. Number 7, what's the y-intercept? So that's f0. f0 is 2 squared minus 8, that's 4 minus 8, that's negative 4. 0, negative 4. How about the x-intercept? The y is 0. This is 8 is 2 cubed. So 3 equals to x plus 2. Therefore, x equals to 1. So the x-intercept is 1, 0. The asymptote, that's y equals to negative 8. The domain of exponential function, of course, is all real numbers. The range, however, let's see. This is 2 to the x, looks like this. And then 2 units to the left, the range still the same, and then minus 8. So it will be from negative 8 to infinity, not including negative 8. Now sketch the graph. So we have the y-intercept is 0, negative 4, 0, negative 4. X-intercept is 1, 0. Horizontal asymptote y equals to negative 8. Now, 3 important coordinates. The base is 2. So originally 0, 1, 1, 2, negative 1, 1/2. Right? We will move 2 units to the right and then 8 units down. 2 units to the right, 8 units down. Oh, I'm sorry, 2 units to the left. That's x plus 2 on the exponent. Yeah, 2 units to the left, my bad. My bad. So it should be here, 2 units to the left, and then 8 units down. It will be here. Okay. 0, 1, 2 units to the left, and then 8 units down. That will be here. Negative 1, 1/2, 2 units to the left, 8 units down. That will be here. Okay, so the graph later on will then be, let me use red color so that you can see the contrast. That's what it looks like. Okay, don't forget, you need to provide me the 3 important coordinates. And then number 8, log base 2 of x plus 4 minus 3. I actually asked this question a lot though. Exactly the same function. I don't think I will do the same anymore. So f0 equals to log base 2 of 4 minus 3. Log base 2 of 4 is 2. So the y-intercept 0, -1, x-intercept set function equals to 0. So 3 equals to log base 2 of x plus 4. Change it into exponential form. That's 8 minus 4. That's x. X equals to 4. So the x-intercept will be 4, 0. The asymptote, x equals to -4. Okay, that's from x plus 4 equals to 0. The argument has to be 0. The argument has to be 0. Okay, the argument is 0 to give you the vertical asymptote. The domain is when the argument is strictly positive. So x is greater than -4. Okay, so from -4 to infinity. The range for exponential function, a log function is a real number. Now we will sketch the graph. X-intercept 4, 0, y-intercept is 0, -1, I believe. So 0, -1, 4, 0. Vertical asymptote is x equals to -4. Now the three important coordinates. Log base 2 of x looks like this. Let's approximate like this. And then this is y equals to log base 2 of x. You don't need to write that one down though, but I want you to see how I actually move the coordinate. 4 to the left and 3 units down. So this guy here, 4 to left, 3 units down, it becomes this. This guy here, the x-intercept originally 4 to the left, 3 down. This guy 4 to the left, 3 down. That's what it looks like. In fact, this guy 4 to the left, 3 down give me the y-intercept 8. 4 to the left, 3 down give me this. So the graph will then be something like this. Okay, this is y equals to log base 2 of x plus 4 minus 3. Okay, now again, don't forget to give me the three important coordinates that comes from the three important coordinates in the basic graph. These are the three important coordinates from the basic graph. Log base 2 of x. Number 9. Find the inverse function. Every time we do inverse function, we need to do, yes, we need to do step 1, 2, 3, 4. Okay, so step 1, y equals to 2 to the x plus 2 minus 8. Step 2, you swap the x and the y. Step 3, you solve for y. So change into log form. So log base 2 of x plus 8 minus 2 equals to y. So step 4, the inverse function is log base 2 of x plus 8 minus 2. Okay, but you need to show me that step 1, 2, 3, 4 though. Okay. Last question. Find the inverse function of this log base 2 of x plus 4 minus 3. Oh, by the way, this was the last question. Actually, both of them are from this number 7 and number 8. We need to find the inverse function. So this is log base 2 of x plus 4 minus 3. Step 2, we swap the x and the y. X becomes y, y becomes x. Step 3, we solve for y. To solve for y here, I change it into exponential form. 2 to the x plus 3 equals 2y plus 4. So y is equal to 2 to the x plus 3 minus 4. Finally, f inverse x is equal to 2 to the x plus 3 minus 4. Okay, that's for the solution of this 419 Math 245 test 4.